78% of the atmosphere is nitrogen, right? And that's something that plants need, among many other things. But it's an important nutrient for plants, but they can't access that nitrogen that's all around them in the air, right? But there is fortunately something that can break apart that nitrogen bond. It's a very strong, like triple bond of N2. Bacteria are the thing that can do that. The plants can't do that. The fungi can't do that, but bacteria can. So that's kind of like their superpower. And so the plant depends a great deal on that ability of the bacteria. The microbes, in return, are dependent on the plant for the carbohydrates that the plant can produce. They basically create networks. These mycorrhizal fungi are kind of sometimes a conduit of nutrients, water, nutrients, and also I think maybe in that cycle that we talked about, the rhizophagy cycle, they might also be delivering bacteria to the plant. This symbiosis between plants and microbes is something that has existed for hundreds of millions of years. And, that's a long time to refine a system, and they've gotten very good at that. And a lot of the things that we need to do in agriculture are about getting out of the way. Not all of it, but a lot of what we could do that would improve agriculture is about getting out of the way of that symbiosis because we've been disrupting it with this chemical agriculture. And so, um, first of all, acknowledge that it exists, and then look at ways we can nurture it instead of disrupting it.
All right, Leo, thanks for coming on. This is our second episode. We did another episode, I don't know, 9 months ago or something like that,
Mhm.
to talk about your first book, What If CAFOs Matter. Today we're going to talk about your most recently published book, What If Soil Microbes Matter. So it'll be available in the description everywhere this is posted, the audiobook, the PDF. But thanks for coming on, Leo. I'm excited to dive into it.
Yeah, thanks so much for having me again, Jake. There's lots to talk about, and I appreciate the chance to do it with you.
Yeah, so I like the title. It's an intriguing title, and I like how you have these question titles. But
Mhm.
um, just to dive in from there, why, when you say what if soil microbes matter, in what ways are you implying that they don't matter?
Mhm.
Yeah.
Yeah, yeah, that's a great starting point. So I'll rewind a little bit to how I kind of ended up writing this book. I think there were some key points along the way that led me in this route. I was making a film called Growing Solutions, and it was about, as the title implies, about doing some more sustainable things in the way we grow crops for food. Um, and so, in trying to solve some of the problems that farmers always have in growing crops. So, one of the people I interviewed for that film is a woman who's a soil ecologist. Her name is Elaine Ingham, and she had a quote where she said she talked about how when she was starting out as a soil scientist, she asked a bunch of soil scientists who are senior to her, what do those microbes in the soil do? And she kind of got the same answer from all or most of them, which was, oh, they don't really do very much. We don't pay much attention to them. Like, don't bother with them,
Yeah.
basically. And she just said that just doesn't sound right.
Yeah.
And so that skepticism sort of launched her on basically a whole career, decades long career of figuring out what they do. What do the soil microbes do? Which, I mean, when she tells that story, it's kind of astounding. Like once you start diving into what bacteria, fungi, other things do in the soil, it's kind of astounding to think that people who are carrying around the title of soil scientist didn't know anything about that part of it. Even though, I mean, we can't be an expert on everything, but it's kind of hard to ignore soil microbes and say that you're studying soil, because I would say that if you don't have soil microbes, you don't have soil. They are what make the
Yeah.
soil. It would be kind of like saying that oh, I have a bunch of soil, there's no microbes in it. It's kind of like saying, well, I've got a forest, at back of my house. There's no trees in it, but it's a
Yeah.
forest. I mean, it just doesn't, that can't happen. They create that habitat, the microbes, among other things, they create habitat that we call soil.
Yeah. And she's the one who had the soil food web, right? The soil food web.
That's
Yeah.
right.
And
Yeah.
can you explain what the soil food web is? Did she coin that term, or is she just the one who's kind of championing it?
No, I'm pretty certain that she coined the term, and basically it's just referring to the fact that there's a whole ecosystem in the soil, just like what we see above ground. It's just that
Yeah.
a lot of it is microscopic, but there's, some of the same relationships, predator-prey relationships, but also symbioses that are very important. In fact, if I wanted to have one take-home message from this podcast, I'll put it out there right now so I don't forget and don't regret it later. Why didn't I say this? My take home message would be that this is something, this symbiosis between plants and microbes is something that has existed for hundreds of millions of years. And, that's a long time to refine a system, and they've gotten very good at that. And a lot of the things that we need to do in agriculture are about getting out of the way. Not all of it, but a lot of what we could do that would improve agriculture is about getting out of the way of that symbiosis because we've been disrupting it with this
Yeah.
chemical agriculture. And so, um, first of all, acknowledge that it exists, and then look at ways we can nurture it instead of disrupting it. Is basically what's that.
Yeah. Um, to me, it just what makes sense logically to me, and we can just jump into the symbiosis thing here, but
Hmm.
it seems to me like if and what I'm struggling to do is track like all the energy and like just conceptually
Hmm.
to back it up, but just in my gut, what I feel is that when symbiosis is at a balance, the energy is the most efficient, like the inputs and the outputs from whatever system we're talking about. If we're talking about agriculture, it'd be the energy into growing the food and then the energy of the harvest. But
Hmm.
it could be for any system. It
Right.
makes the most sense to me that symbiosis leads to efficiency. And I think the issue is that like people we are optimizing for variables that don't encompass the full, like you said, we're not thinking about microbes as until recently even a factor at all, let
Hmm.
alone the factor that is as important as it should be. But yeah, so we're kind of like disrupting the symbiosis and optimizing for certain variables, generating those outputs, but in the process we're kind of getting in these loops where we're losing the efficiency.
Yeah, and I think that's a good word to use as the loops because I think I write about it in the book about how the synthetic fertilizers and the pesticides, by using them, we kind of necessitate their further use.
Yeah.
Because if like for instance, just to be more concrete, there's research that shows that when you use all the synthetic nitrogen, you end up depleting the nitrogen in the soil over the long haul. And so then, of course, then the farmer needs to keep using the synthetic nitrogen. Whereas if they
Yeah.
back off of that, then nature takes over. I mean, I like to think in terms of superpowers, and I don't know if I said this one the last time you and I spoke, but you know, the, there's this strange phenomenon that 78% of the atmosphere is nitrogen, right? And that's something that plants need, among many other things, but it's an important nutrient for plants, but they can't access that nitrogen that's all around them in the air, right? But there is fortunately something that can break apart that nitrogen bond. It's a very strong, like triple bond of N2. It's just two nitrogen atoms bonded. And bacteria are the thing that can do that. So, and the plants can't do that, the fungi can't do that, but bacteria can. So that's kind of like their superpower. And so the plant depends a great deal on that ability of the bacteria. Now, of course, the bacteria and all the microbes in return are dependent on the plant for the carbohydrates that the plant can produce. I mean, the plant's superpower is it takes solar energy that we can't eat, and the microbes can't eat solar energy. They don't have that capacity. But the plant luckily converts sunlight and other elements into carbohydrates that are then chemical energy that fuels bacteria, fungi, all these. We're all carbon-based life forms. So it all starts with carbon. And when you have a well-functioning ecosystem, it's like a carbon factory. It's just constantly pulling carbon out of the atmosphere. And a lot of that carbon goes into the plant itself, but a lot of it is delivered to microbes in the soil. It's shared, and that's the nature of the symbiosis. So it's just not the kind of thing you want to try with. You don't want to mess with that kind
Yeah.
of success. I mean, these things have been, again, as I said, have been developing for hundreds of millions of years, these systems. So we're being a little naive when we think that, well, the plant needs nitrogen, so let's just pour a whole bunch of nitrogen into soil. Problem solved. It doesn't work. It isn't that simplistic. We're applying a simple logic to something that's very complex.
Yeah. And then I know in the last conversation we had, we talked a lot about the shift from the chemical age to the biological age, and that's kind of the
Yeah.
the goal of behind a lot of what you're doing, and a lot of what other researchers and regenerative farmers and stuff like that are doing. Um, yeah, it's getting back to like these idea of these loops. Like, um, there's not negative and positive feedback loops. So I always mix them up. But
Mm.
the negative is like the one where you end up right back at zero, right? Whereas the positive is it doesn't cancel itself out. It kind of spirals, um, where it becomes a dependency cycle in some way or another.
Yeah. Well, I think it's one of those strange things where sometimes what's a positive feedback is
Yeah,
something you don't really want. So
yeah, it's
it gets
counterintuitive.
confusing. But um, but I think what you see in the soil is that if you have an abundance of microbes and a diversity of microbes, then you just have this very robust system. It's like, because the one thing about it is when you have diversity among, say, the bacterial species, all these different species of bacteria do different things. They perform different functions in the soil that are, beneficial to the plants, along with other creatures too, are doing things. Um, bacteria, for instance, they make phosphorus available. Just to name one nutrient, they can the word they use is solubilized phosphorus, right? And phosphorus, again, like nitrogen, phosphorus is a really important nutrient for plants. But the thing about okay, so the thing about phosphorus is it binds with metals in the soil. Like it's considered a very immobile nutrient in the soil. It's even if you're a farmer, you put lots of phosphorus on your farm fields, you could test them, I don't know, a few weeks, few months later and find, oh, there's no phosphorus here. And that's
Hmm.
because the phosphorus doesn't show up in a soil test because it's bound up with metals.
Okay.
So so that's something, but the bacteria luckily are able to what they call solubilize the phosphorus, which means bring it back into a form that plants can access. Basically, break those bonds. The phosphorus is
Okay.
bound up with metals. The bacteria can break that bond, and then the phosphorus becomes available again to the plant.
I remember I did a podcast with my cousin Mike. He's a soil biologist, but he was talking about the nitrogen and the process bacteria does to break it down. I forget exactly, but I
Hmm.
remember him, and I forget the numbers, but he was saying, I'm pretty sure it was the most energy intensive part of factory farming in general is um, taking that nitrogen from the air and uh, bringing it into a solid. Um, what is that, breaking N2 down to N1? Is that what's happening there?
Um, well, I think what they end up with is either nitrate, which is NO3, or
Okay.
ammonium. Actually, fungi create ammonium, which is NH4. It's just a different form of nitrogen in a different form. But I
Hmm.
think most of the synthetic fertilizers are either urea or they're nitrate. A lot of nitrate
Okay.
is used. But the weird thing about so that's the other thing when they use these synthetic fertilizers in there, if they're nitrate, let's say. So when a plant wants to make proteins, all proteins have nitrogen in them, right? But it's like a two-step process to create a protein. You start with the nitrate, let's say, and then you create amino acids from those nitrates plus other things, and then the amino acids are the building blocks of the protein. Now, if the microbes are delivering, they don't deliver nitrates to the plant, they deliver amino acids. They do that first step for the plant. So it's
Okay.
less energy intensive for the plant. The strange thing that happens is if you have too much of that synthetic nitrate in the soil, the plant will actually have like a backlog of nitrate in its system. It will be sucking up that nitrate, but then it doesn't have it can't process it fast enough. It can't turn
Yeah.
into amino acids and protein fast enough. And in fact, it can be a problem in pastures where animals then eat those plants and they're getting an overdose of nitrate and they have all these health problems that are caused by excess nitrate in their diet, which would never happen if you weren't using synthetic nitrogen. You would never have this issue
Yeah.
because the plant wouldn't be acquiring nitrogen in that form of nitrate. So it's kind of something that's missed too, and it's a nuance that's kind of missed when they just say, "Oh, we need nitrogen," just throw it on the farm field as nitrate. The other thing that's not very helpful is, of course, the plant needs these nutrients at a certain time. It doesn't just take up every bit of nitrogen, say that you put on synthetic nitrogen you put on the field at one time. It takes it when it needs it, right? And so that's where the microbes come in handy also because they're constantly turning over nitrogen. There's this whole nutrient cycle that's happening in the soil.
Yeah.
And so the plant can then access it when it needs it. It can get the nitrate when it needs it. And otherwise you end up usually with a lot of nitrogen seeping through the soil. It's a very it's the opposite of phosphorus. So I mentioned that binds up a lot of things. Nitrate tends to be very mobile in soil. If there's a big rain event or something, or even irrigation, a lot of that nitrate will seep through the soil. And so that's why we have sometimes excess nitrate in, bodies of water and things like that. So it's
Yeah.
not a very efficient. I mean, in agribusiness, they talk a lot about efficiencies, but they do so many things that are actually inefficient from an ecological standpoint. They might look efficient, like within a sort of, there's an internal logic to it, but it doesn't really account for a lot of factors, like these ones I've been
Yeah.
describing.
Yeah. It's overemphasizing little details. It's kind of I'm only starting to dig down this regenerative agriculture rabbit hole. I've gone a little deeper down the nutrition one, and it's kind of like saying like we as humans need carbohydrates. Let's all just drink corn syrup, you know?
Yeah,
It's
yeah, right, exactly. Yeah,
yeah, it's like
yeah, yeah,
it kind of makes
yeah.
sense, and it's in some ways like it is what we want. Like it's biologically like it's satisfying at least initially, but we end up
Yes,
in these loops where our health is compromised.
yeah,
And it's yeah,
sure. Well, I keep seeing more and more things that match up between plants and humans. Like we're not as different from plants as we may think.
yeah,
They actually have a very complex diet also. They need, if you look at a list of the minerals that humans need and the ones that plants need, they almost overlap completely. Although I found that some of the lists are a little bit different, but in general, they seem to overlap almost completely. And I think they do some of the same things in our bodies that they do in, a certain mineral do the same thing in a human body or something equivalent to a plant. But for instance, like well, the like manganese is one of the nutrients. I'm like ticking off different nutrients here for you, but manganese is a metal that is in the soil and it's needed for photosynthesis. There are several things that are needed for photosynthesis, and that includes manganese. Now, it's kind of like I equate it to like a shoe factory where you have all the things you need for to make shoes, like whatever, 1,000 pairs of shoes today. But if you don't have any lacings, let's say you only have lacings for 400 shoes, then that's your limiting factor, right? You can
yeah,
only make that many shoes that day, right?
yeah,
And it's kind of like that with photosynthesis. If you have everything you need, the plant has the sunlight and the water and everything else it needs, but it doesn't have manganese, then it's gonna put a ceiling on what it can do in terms of photosynthesis. In fact, a lot of people say now that like that is one of the keys to making agriculture more efficient is to actually recognize all the things that the plant needs for photosynthesis and make sure it has all those elements. Now, here's a complicating factor. Like, so here's something agribusiness does. They use a lot of glyphosate, which we know is a Roundup usually, right?
hmm
But glyphosate is the chemical name. Glyphosate actually binds with metals, including manganese. It binds with iron, it binds with manganese, it binds with other metals in the soil. And what that does then is make those things unavailable to the plant, right? In fact, there's research that shows that there's there's iron deficiency in a lot of the soils that where they've used glyphosate for years. It's leading to an iron deficiency, and so that's going to obviously hurt a plant's prospects as far as doing photosynthesis at its highest possible rate. It's going to be have a ceiling on its production in a way.
yeah. That's when I'm training. Always have this term bottlenecks, where that's kind of what you're talking
Yeah.
about, the hinge point in the system. But
Yes.
I just think when training an athlete, you want the focus on the bottlenecks. That's going to be what leads to the highest results. You know, if you've got a
Hmm.
compensation and the way
Yeah.
your knees are when you're squatting, like you can get your glutes as strong as possible, but until you fix the knees, you're going to be stuck at that hinge point.
That makes sense.
Progress
Yeah.
in other areas isn't really going to help the overall ability.
Yeah. And just to continue what I was saying about the photosynthetic rate, like if the plant's doing less photosynthesis, well, the follow-on effect is that means the microbes get less food because they're dependent on the plant. So that means you're going to have less abundance of microbes. And that's what, they drive the system, And like the bacteria kind of like the basis of the food system within the soil. Lots of things eat bacteria. And bacteria have a lot of nitrogen in their bodies. So when something eats it, anything that eats bacteria tends to then have more nitrogen in its body than it wants. So what does it do? It expels that nitrogen. Well, that nitrogen waste product is like a boon to the plant. The plant can now access it. So there's that too. If you're slowing down photosynthesis, then the whole system is slowed down, and it's just not gonna get as much nutrient cycling.
Yeah.
That was an effect right there.
Listen,
Special effect.
yeah, you can tell you've been recording audiobooks. You've
Yeah, right.
got a heightened sense of pacing.
Yeah, so I mean, yeah, when you start thinking about this, I mean, that's the thing is those things haven't been considered by agribusiness. I should mention though that there are a lot of farmers now who are paying lots of attention to this. It's not like that's not universal, of course. That's just more in the conventional ag world. But there are, regenerative farmers who some of them are testing their soil for biology, and that's what the future is, I think, is to instead of just testing for the chemical elements of the soil, the mineral elements, you test for biology, because it's biology that goes and gets the minerals that the plant needs. If that isn't there, then they won't be able to access. Even if you have a soil test to show that there's lots of minerals in here, if you don't have the microbes,
Yeah.
you need those enzymes the microbes have to break down, um, physical elements of the soil to access nutrients.
Okay. I, I did an episode with James White, who you mentioned in your book. And
Yeah.
honestly, I reached out to him after our previous episode because you mentioned his work. But
Hmm.
he does the Rhizophagy cycle, which is kind of what you're getting at here, which is how there's this cycle where plants are um yeah, they create the rhizosphere where they're expelling nutrients for the microbes. The microbes are generating in that sphere, clustering in that sphere because of those microbes, and then they're expelling nutrients for the plant. So it ends up being this symbiotic relationship.
Hmm.
Um,
What makes it the rhizophagy cycle takes it to another level in the sense that he describes how um, the plant actually takes up bacteria, let's say, into its body,
mhm.
and then like extracts nutrients from it, and then but doesn't it isn't consuming or digesting the bacteria because it puts it right back out into the soil. So it's creating this cycle where you pull in bacteria, you take out the nutrients, and then you deliver it back to the soil where it can go get. It's like go get me some more nutrients now.
Yeah,
Which is what I don't know is what percentage of the delivery of nutrients happens in that way. It's very
yeah,
intriguing. And I think that's one of those unanswered questions out there because there's other ways that plants access nutrients, but that is a very intriguing one without a doubt. It's kind of it's a great discovery.
yeah. That's yep. In that conversation then, and in this conversation now, I'm trying to like visualize how this all works, how
Hmm.
the plants, the microbes, and the nutrients all flow together.
Hmm.
One of the core things I'm missing, I'm curious if you understand it, is like what's propelling the flow? Like what does are the microbes like, you know, picking up their mini knapsacks, throwing some metals, into the knapsacks and
Hmm.
backpacking into
Uh,
into the root, or is it are the roots sucking it up? Like,
no,
yeah, what's driving like
yeah, yeah.
the movement?
That's a great thing to bring up because I think what you're hinting at is what's the communication between the plants and
Yeah.
microbes, maybe, because that is something that's happening. Because I mean, once you start thinking about, okay, so the microbes are getting these nutrients for the plant, how do they know how much, say, manganese to get for it, and when does the plant need it, and in what quantities? Well, there has to be communication happening, right? And so scientists are finding that there's this whole communication network in the soil. What they call it is chemical messaging. And I don't know the
Hmm.
details of that, but basically the plant puts out chemicals that are almost like it's like coded messages, you could say in a sense. I don't know it on a detailed level, but that is how communication is taking place. And it makes sense. Like, how could they possibly do all these complex things unless they're able to communicate with each other? And there's also I don't know if I mentioned this last time we talked, but there's this phenomenon called quorum sensing, and it's something that bacteria do. What It's kind of interesting. There's a woman named Bonnie Bassler who's, I think her work is very interesting. She looks at bacteria and how they communicate. And they actually have like two like portals, ways that they receive messages, right? Like chemical messages. But one of them is like their private, you could think of it as a private Facebook group. And that's where they communicate with other bacteria of their own species. And so that way they can
Interesting.
sort of they can like figure out what's going on among themselves. But then they have another portal that's kind of like it's the public facing Facebook page, if you will. So that's where they can receive messages from other types of bacteria, other species. And it's kind of amazing that what will happen is the quorum sensing leads to sometimes different species of bacteria pooling their skills, if you will, to get something done for a plant, let's say, because they each have different things they specialize in. And again, I don't know this on the detail level, but it's fascinating to think that they're kind of getting the lay of the land. There's another microbiologist I'll mention is Christine Jones. I mentioned her in the book a few times, and she talks about how bacteria in the soil, they can sense if there's a microbiome that's near them, but it's very similar to them. If the bacterial species is a similar mix of bacterial species, well, they will not then associate with that other microbiome because they figure, well, they're doing the same thing we're doing. We don't need to collaborate with them. But if they sense that that other microbiome is sufficiently different from them, meaning that it increases that their collaboration would lead to increased functionality or whatever, then they will collaborate with that other microbiome, which is very fascinating. And so
Yeah.
that's how you get You also have these symbioses in a sense among many species of bacteria, which is also quite astounding.
Yeah. When I was listening to your book, I was kind of starting to think of it all as a system. And at some point it hit me, and this is like a few why questions deeper than we are. So it's, um, but, like my consciousness, what is me and what is the bacteria in my body? Like,
Yeah.
am I a product of like everything in me that's sterile, or am I a product of like everything in me plus all the microbes? Yeah. So, and I think it's the same for plants. Like, is the plant just the plant, or do the
Yeah.
bacteria and the roots also, is that also the plant? And I don't know. It's
Yeah.
interesting
I,
to think about. Like, where's the distinction?
yeah. Yeah. Well, and that brings up a word that might be useful to you. The word is holobiont, and it's kind of like it's almost like I don't even understand it entirely, but another scientist I'll mention is Dr. Adam Cobb, and he helped me with this book. Like he was a reviewer for this book, and he really helped me a lot. Just checking on the science of it all. But he has a website now called the Holobiont Hub, and a holobiont is kind of like what you're describing. It's the sum total of all those creatures that are depending on each other. It's like a symbiotic, complex or whatever you want to call it. And so, yeah, it is hard to say, well, where do you separate the plant from the
Yeah.
microbe, especially when you consider that a healthy plant will be covered in microbes, every part of it, the leaves, the stems, and they create this kind of, very strong defense against anything that would want to harm the plant. So, that's it's kind of astounding, like you would never think that. And the other thing I thought about when I started looking at this, one of the when I took these soil ecology courses, one of the microscopic pictures was of a plant leaf, and it shows bacteria all over the leaf. I mean, covering the leaf, and also fungi covering the leaf. And I thought, well, that's a healthy leaf. The unhealthy leaf is the one that doesn't have enough bacteria
Right.
and fungi on it. They're defending. But then think about that. If you're eating raw, like raw lettuce or whatever, because that stuff isn't going to wash off. We think, oh, we wash our food and everything, we wash off all the bacteria. Well, you actually don't want to wash off all the bacteria, and luckily you won't be able to. But it puts me in mind that eating that raw food is extremely good for us, because you mentioned like fermented foods, which are also great. But even just eating that food, that plant, that and the fresher it is, the more of those microbes I assume will be alive still. So if you're eating it like fresh out of the garden or whatever, you're getting all these great microbes that are great for your gut, because your gut is again full of microbes, just like the soil is, just like that that rhizosphere is full of microbes. See, and I think also the other thing you hear, I think that I would alter the way people talk about it. They say, "Oh, microbes help you digest your food." I'm starting to think that they don't help you digest your food. They just digest your food.
Yeah.
I'm not certain that that's a true statement entirely, but I am starting to have an inkling that might be true. So that's another reason I kind of want to dive into that more deeply, the gut microbiome, because it has so many parallels with what happens in the soil.
Yeah, I've been getting more and more interested in that too.
Yeah.
Are you are you familiar with fascia throughout the body? That's another area I've been getting interested in.
I
It's
haven't, yeah, I
it's
haven't looked into that.
it's kind of just as an analogy. So fascia is cool. You've got all your muscles, and every single muscle is surrounded by a layer of fascia. All the fascia is connected throughout the body, and the fascia is
Hmm.
like it goes through the muscles too. But
Hmm.
there's also like thin layers around the outside, um, and it's what's cool about fascia is that it can change shape, and
Hmm.
it's kind of like the microbiome. It's people don't really understand it, but
Yeah.
especially over the last 50 years or so, people are understanding it a lot better than we used to.
Hmm.
Um, and it changes shape based on the electrical signal, as best I understand it. But it can kind of be hard or soft.
Hmm.
When you get an injury, it'll calcify like the fascia,
Hmm.
and it kind of like you create a splint basically
Hmm.
to prevent motion while the injury heals,
Wow.
and that becomes scar tissue. Uh, but anyways, it's like fascia is what connects everything throughout the body, and
Hmm.
there's these signaling through it. It's electrical signaling through the nerves,
Hmm.
but it's pretty similar to like the bacteria around plants. You know, it's we've got the plants, and then we've got layers of bacteria, or I'm saying bacteria, I really mean microbes, layers of microbes surrounding the plants. Um, and even when the roots of one plant ends and the roots of another plant starts, the microbes are all connected, kind of connecting one plant to the other, the same way the fascia is kind of connecting one muscle to the other. And so
Hmm.
the fascia is really key to fluid motion, you know, where you're using your whole body for one movement because everything's coordinated through the fascia the same way. Everything flows through
Hmm.
uh, the microbiome underground through the microbes. It's kind of interesting.
Yeah. I
Um,
mean, this isn't a perfect analogy, but you remind me a little bit of what the fungi do because they basically create networks. You know, these mycorrhizal fungi are um, kind of sometimes a conduit of nutrients, water, nutrients. And also, I think maybe in that cycle that we talked about, the rhizophagy cycle, they might also be delivering bacteria to the plant. I'm not sure about that part, but they're definitely a transit system and a very important one. And so that's kind of in a sense, you could say their superpower. They also store a lot of carbon because the fungi are very carbon based. They create very complex carbon compounds. So in a sense, they're kind of like a perfect counterweight to bacteria. Bacteria, like they have the short lifespan. They turn over nutrients quickly. The fungi are more like they're like the slow burn. They grow slowly. They create more complex compounds. They also create a lot of stability in the soil for nutrients. They'll stay in the soil a long time because of the way fungi can process them. And um, so yeah, they're very critical. And it's interesting because um, one of the myths now I see it as a myth is you'll hear like legumes. You want legumes to fix nitrogen for you. Sometimes farmers use that, and
yeah,
that's true. Legumes are great as a way to get nitrogen into your soil. But first of all, of course, it's not the legume that's fixing the nitrogen; it's the bacteria that do it. But they associate with legumes. But in addition to those, so you can very much see um, if you pull up a legume and on the roots, they usually have these nodes on there that is where the bacteria have kind of taken up residence, and it becomes like a transfer station for nutrients for nitrogen.
it's
And
just
and so, but not all bacteria behave that way. They're not all what you call rhizobacteria. Just means it's on the root system. Some of them are what they call free living bacteria. They're out there in the soil. They're kind of rogue, or whatever you want to call them.
yeah.
But they will still, some of the nitrogen they produce will get to plants, but by way of fungi. Again, fungi being the conduit for these things. So the fungi also, I don't know if I mentioned that they're messaging, like a lot of the messaging that happens in the soil is, the fungi are they're like the internet of the soil in a sense. They're
Yeah.
connecting all these different creatures and allowing for communication to also happen.
Are the fungi actually moving the bacteria or are
I,
the yeah?
I
I'm
think
still trying to. I'm still stuck on that. Like what what's propel like what energy is being burnt or to move? Like I'm sure something that has to go against gravity is a do the plants create like a pressure system, like like an engine, where the fluids run
Yeah.
circulate through, and like
Um,
where is it all? Yeah, I don't know what.
yeah, I don't know enough about that. But definitely
It's interesting.
I think bacteria are moved through fungi in some cases. I think that I
That's
have
cool.
seen that that happens. Yeah. And they also, of course, they're consuming some of the bacteria too. You know, it's kind of like it's probably equates to the plant. The plant makes all these carbohydrates. It doesn't give them all away. It just gives
Yeah,
away this, what it can spare, basically.
yeah,
I've made my leaves and stems and whatever else and roots, and now I'm gonna give some of this carbohydrate to the microbes because it knows it gets something in return, and it
yeah,
can't even do the process it uses to create those carbohydrates. Well, it couldn't do them without the microbes because they provide things like manganese and iron and other things that are needed in photosynthesis. So they definitely, I mean, that's the nature of symbiosis, right? It's a transaction. It's
hmm,
like you do this for me and I'll do that for you. And it kind of has been working for hundreds of millions of years. So,
yeah,
it doesn't really make a whole lot of sense to mess with it, but that's what we've been doing basically. But, we didn't know. I mean, there's things we didn't know. Now I feel like that's why if I have hope, it's like there's a lot of realizations that are happening now. It's just unfortunately like they're oftentimes below the radar and most people don't know about them. But I will say too, the farmers are kind of leading the way on a lot of this stuff. They are, experimenting with all these different methods but it's the methods that they're trying are based on what they know now about the biology in the soil. They're not
yeah,
totally, shooting into the darkness. They have some idea behind it, some philosophy behind what they're doing. And a lot of it is just mimicking nature too. Like they see how nature operates and it's not the way that conventional agriculture operates. You don't have monoculture in nature, You don't see a field where there's if it's in, natural habitat, there isn't just one plant growing across, many acres, It just isn't, nature operates off diversity. Just like
yeah,
the kind of diversity I was mentioning in the soil with the bacteria. I mean, they have diversity because different plants do, or different bacteria do different things. In the same way, like in a prairie, you have all these different kind of plants because they do different things and they thrive at different times of the year. So they kind of keep the factory, that carbon factory, up and running all year long because they each one thrives at a different time.
yeah. It's. Do you think there's a direct correlation between diversity and I was gonna say health of the system, but I really mean like efficiency of the system.
Well, you could say that that is, I mean, efficiency in a sense
Yeah,
is part of the health of it. Yeah. Oh,
yeah,
there's no question that the diversity is going to lead to more efficiency because, again, it goes back to my shoe factory. If there's a certain species of bacteria that's missing from the system, then, well, there's some functionality that you don't have. I'll go back to Christine Jones, she's an Australian microbiologist, and she talks about, like, let's say farmers have gotten this idea that they should plant cover crops, and that's a great thing. That's way better than having, bare ground. That's something we should try to avoid that. That's one of the principles in regenerative agriculture is avoid having bare ground
hmm,
whenever possible, because it's basically bare ground is like shutting down the carbon factory, right? It's like saying
yeah,
we're not gonna bother to, bring in any carbon right now. So basically you keep that carbon factory up and running, but by having a cover crop. But if the cover crop is just like hundreds of acres now of a cover crop, you've just created a different monoculture instead of having corn or soybeans. And it's better than bare ground, but you can do even better if you now a lot of farmers will do what they call like a cover crop cocktail. They just plant a whole bunch of plants in one field, and that way they're mimicking the diversity of a prairie, let's say, right? Because it's a polyculture instead of a monoculture. And even Christine Jones says, take it even one step further, because some plants you could plant a bunch of cover crops that are all from the same plant family, and that plant family will have similar functionalities in the way it interacts with the soil, let's say, and the soil microbiome. So you want to have plants from different plant families in order to maximize the efficiency of the system.
yeah.
Because again, they're different plants do different things, different bacteria do different things. So if you have them all working in concert with each other, that's going to maximize your efficiency.
All right. So, um, I want to talk about the future a little bit. We've touched on it, but I want to just focus on that.
Hmm.
You've mentioned hope. You've mentioned, and we've got people like you doing the research. We've got people, the farmers. You said leading the way. They're learning things from like a cultural perspective. What do you think the bottlenecks are in terms of integrating this on a higher scale?
Well, some of the biggest barriers are you have a system that's very established, right? You have that industrial system that's very chemical based.
Um,
There's a whole lot of money in that, in
yeah.
those inputs, Farmers are these regenerative farmers are finding they can wean themselves off all those inputs, save a ton of money. But, of course, there's going to be, I feel like whenever you have profit, propaganda is not far behind, right? There's
Yeah.
going to be people who are going to tell you that you can't grow these crops any other way. You have to have these synthetic inputs. And it's not true. But if a farmer hears it enough times and that's all they've ever heard, then I mean, I can't really blame them for thinking that's a huge leap to think that they could, get rid of all that stuff.
Hmm.
So, I mean, a lot of it is just like it's a propaganda war, basically, in that sense. And it's like, I think a lot of the good stuff that's happening already, and hopefully will happen more, is just that farmer to farmer, like peer network, because there
Hmm.
are farmers who are kind of showing the way that always have those pioneers, those early adopters who are showing that you can not only decrease your inputs and save money that way, but you're also getting better yields. It's like you're winning at both ends. And that's
Yeah.
the opposite of what a lot of conventional farmers are finding, that they're spending so much money on inputs, the prices are often going up on those inputs, but the prices they receive for their outputs is not increasing at the same level. So of course that's making their profit margins smaller and smaller. So, I mean, I think basically that if there's something that's hopeful in this, it's actually in the crisis that industrial agriculture is in. I mean, I hate to say it that way, but it's like sometimes humans, we only seem to respond to crisis. And in that film I mentioned, Growing Solutions, Gabe Brown, a North Dakota farmer and rancher, he describes how he had 4 bad years in a row of conventional farming. He was a very chemical-based farmer, just like most everybody else. He had these terrible years where he lost money, and then he couldn't afford the inputs anymore. He couldn't, he had to, as he said, I just had to find another way to farm because I didn't have another choice. And so he started, experimenting with not using the inputs because he couldn't afford them anyway. And now he is like a leading spokesperson for regenerative agriculture, which is an amazing transformation. But his transformation was born out of crisis. He didn't just read a book one day and say, "Oh, I'm going to change my whole farm around." He was in a pickle, economically, and that caused him, out of crisis came opportunity, in a sense, you could say. Hopefully, every farmer doesn't have to get to that crisis point before they
Yeah.
change, but I think unfortunately, a lot of people will, and other people will probably just see around them. Eventually, when there's a critical mass of farmers who are doing it without the chemicals, then it'll be hard for other farmers to ignore that success. That'd be my hope. Um, yeah.
If we were to use more technology in farming, like and track the data, and I assume it'll become that way with AI and everything. Um, what types of data do you hope we're tracking? What do you hope are the indicators we're using to measure the efficiency of a farm, or what would make sense to you?
The most important thing to measure is how much biology do you have in the soil. That is that's your measure, because
And
that's
is
going
it
to
just mass, just as a like
no.
a ratio?
No, it would be diversity and abundance of
Okay.
both bacteria and fungi, and that's what they don't test for now in conventional ag. I mean, you only find what you look for, right? And so if you're not looking for that biology in the soil, then you don't even know that's a factor, right? And the other thing, a lot of stuff. It's interesting because in the conventional ag world, sometimes they pay attention to things like they talk about organic matter in the soil, right? And how they've lost a lot of organic matter. I guess conventional farmers too understand that organic matter is important, but they might not understand exactly why it's important or where it comes from. And it does come from having that efficient turnover of nutrients in the soil. Because I mean, so if you asked me to define organic matter, I would say it's kind of the sum total of all the living and dead things in the soil. So all the things that are either living still, or they're like carbon-based life forms that are now dead, but now they're food for something, right? And that stuff is just turning over and turning over. But if you're doing things like tilling and leaving bare ground, well, it's not surprising that your organic matter would go down, right? Because,
Yeah.
well, first of all, a lot of what happens, and I did want to talk a little bit about climate change because I think that we don't sufficiently appreciate the contribution of conventional agriculture and tillage to climate change. Because when you till, a tremendous amount of carbon is released from the land, right? That would otherwise be um, bound up in living things or in the organic matter, the dead things. It's still there, and it still can be cycled, right? But if you, what happens when you have a tillage event? Let's say you till up a farm field. Well, first of all, you're killing off the fungi because the fungi are these long strands. It's a creature that's just made up of long strands, right? And so you can just imagine tillage equipment just
Uh-huh.
cutting up all those strands and killing that fungi. Most of the farm or conventional farm soils are going to be nearly devoid of fungi, maybe even completely devoid of fungi, right? That's very significant in terms of storing carbon because as I mentioned earlier, the fungi are the carbonaceous plant. They're very carbon heavy creatures,
Yeah.
and it's also a very stable storehouse for carbon, right? And so right there, you've lost all this carbon storage capacity by tilling, right? And then you also, what happens when you till, the bacteria, there'll be this feeding frenzy that happens in the soil because now when you till, all the organic matter is also ground up more and you have all this extra surface area. It's easier for the bacteria now to access. Certain types of bacteria will have a feeding frenzy on that dead organic matter because now they can access it more easily. And also, there's less, there isn't things like maybe bacterial feeding fungi. There's less of the creatures that feed on that kind of bacteria. So this whole feeding frenzy then releases tremendous amounts of carbon because, as I mentioned, um, bacteria have a high level
Just
of nitrogen in their body, but they have less carbon than other things. So for them, carbon is a waste product. They want less
100%.
carbon in their body because they want to have a higher ratio of nitrogen in their body than other creatures do. So carbon, when they eat things that are very high in carbon, well, they need some carbon, but they always get more than they need because these other things they're eating are always going to have a higher ratio of carbon to nitrogen than the bacteria have. So it just stands to reason that's now a waste product for them. They blow off that bacteria, they blow off that carbon, and where does it go? It goes into the atmosphere because there's nothing there or there's not enough stuff there to absorb the carbon. In a healthy soil, that doesn't, the bacteria putting out carbon waste product is not a problem because there are other things that love that carbon. They want it, right? But once you've made it a bacterial dominated soil, well, you're asking for trouble. Now you're going to have a lot of off gassing of carbon, actually. So you've done two bad things in a sense. By tilling the soil, you've taken away the plants, right? And the plants are the beginning of your carbon factory, right? They're the ones who bring all this carbon out of the atmosphere. You've said no, we're going to just wipe out all these plants. So you've shut down the carbon factory, but you've also released all this carbon that had been stored in the soil. So it's like a double whammy, and that's not really talked about enough in our discussions of climate change. It's really unfortunate because if we change the way we farmed, we would just store tremendous amounts of carbon. And the other thing that's undervalued is that soil can be created very, very rapidly. We learn now. When I was first starting out in this industry, in this profession, they talked about it takes 100 years to form an inch of topsoil, and that's just not true. Now we know that it's not happening. We thought before that it was just like the leaf litter and things like that on top of the
Uh-huh.
soil being broken down into soil, and that's the only way it was created. And that is some of the soil is created that way, but most of it is created by this process of plants taking carbon out of the atmosphere and putting it into that microbiome and the way the microbiome processes it. That's where most soil is created there, not by this leaf litter or whatever else on top of the soil. So that's more understood. Like some of the numbers, and that's another thing we can track. You talked about what data can we track? Well, we should start tracking the success of these regenerative farmers in building soil very rapidly. And in so doing, of course, if you have more soil, you're going to have more carbon because more soil means you have more microbes, and all those microbes are carbon-based life forms. So it just stands to reason that that you're increasing your carbon content of your soil if you're increasing your bacteria or especially your fungi actually.
Yeah.
So yeah, the other thing too is I just want to mention before I forget that a healthy microbiome in the soil will also store more water because all these things need carbon, right? They're carbon-based life forms, but they all living things need water too, right? So again, it stands to reason if you have more of that life in the soil, you're going to store more water. And water vapor is actually a big part of the climate change problem. It's, I think I quoted something from NASA
Yeah.
in there, how it's the most important greenhouse gas,
Hmm.
or most abundant greenhouse gas, they call it. So that water vapor, instead of it being in the atmosphere, it would be in soil where it's more appropriate, where it had been before we started doing so much tillage. So that's another factor. And you notice
Yeah.
like when these big storms happen, there's these hurricanes and they say, 9 inches of rain fell on Houston, and it's like, and we never had that before. Well, it's because these hurricanes have more water in them because there's more water vapor in the system, in the atmosphere than there used to be. And so that's just fueling these big storms and making them bigger in terms of the water content of the storm.
Yeah. I think it makes sense like a math problem that you could calculate all the carbon, nitrogen, water vapor in the air and
Sure.
understand the ratio of plants,
Hmm.
um, fungi, bacteria in the ground, or at least get it has to be heavily correlated. Um,
Yeah, and I think too, though, that some of these things, it's great if you can have data on all these things,
yeah,
but some of it is almost just common sense. You know what I mean?
yeah,
Like you don't need to necessarily track everything. If you are doing things in this regenerative way, you're going to have good outcomes on all these measures, even if, whoever the government doesn't want to fund that or whoever it needs to be collecting that data,
yeah,
if they're not collecting it, it doesn't mean it didn't happen. You know what I mean?
yeah,
So yeah, ideally it'd be great to track that stuff. Also, it's great to track it so that farmers can be rewarded for these things they're doing, because they're creating a societal benefit. It's not just it's benefiting them, sure, but if they're helping to mitigate climate change and actually reverse climate change, that's a huge, obviously a huge societal benefit. Why not, compensate them for that in the way that you can't compensate them if you can't measure any of it, obviously.
yeah,
So yeah, so you're right. Data, I mean, the data collection would be great. Ideally, you'd want that, but you don't want to wait around for the capacity to measure it all and not do these things until you can, what I mean? Don't wait to
yeah.
be able to
It's
measure it all before you do it.
Yeah, we need some trailblazers like yourself, like a lot of these people out here that are, um, spending their energy making progress. But I think ultimately it's got to get to the point where people like get credit for making decisions that,
Yeah.
yeah, and I think that's what's lacking right now is people don't get fair credit for what their impact that they're making.
Absolutely. And that comes back to, what do we know about the soil? And most people don't know that much about the soil biology. And that's also that the other long-term thing is the education piece. Like,
Hmm.
are we going to give people more ecological education so they understand why this stuff is important? Because otherwise it's kind of like it's really hard to get people interested in something if they don't have that foundational knowledge, that leads to them being curious to find out more. I mean, you can't kind of that's why I started the book by listing the things that microbes do. It's not an exhaustive list, but a lot of these things that microbes do in the soil that are beneficial, and then describing them in a little bit of detail without getting too much in the weeds or whatever into the science of it. But I felt like if I didn't explain that, then the rest of the book wouldn't really make sense, or it wouldn't all resonate because you don't know why it's important, you know, unless
Yeah,
you know the basic science. The basic science is the starting point, and you don't have to know it on a detailed level. I'm not suggesting, I don't know it on a real detailed level, and I'm not suggesting everybody else has to, but they have to at least understand the basic concepts, and that leads you to value soil biology, and then by extension, value regenerative agriculture as something you want to support as a consumer or an activist or whatever it might be.
yeah. Interesting. So you mentioned that you're interested in the microbiome, human microbiome. Is you
Yeah.
said you're going to focus more on that going forward, or is that more like a side project that you're getting into, or
Well, I would just say that it's a natural outgrowth of what
yeah,
I've been learning about the soil biology. And it's funny because earlier in this conversation you mentioned my gut, your gut tells you. And I've
yeah,
even read, I think maybe you've read this that the microbes in our gut actually affect our decision making or our emotions.
yeah,
So there's actually something too when you say, well, my gut tells me this. It's like, I don't know that again on a detailed level, but
The
it
second
makes a lot of
brain.
sense.
That's called the second brain in a lot of
Okay,
schools of thought.
gotcha. Yeah, yeah, yeah. And a lot
Yeah,
of the health things, like I know you're interested in health. I mean, I've been reading more and more about how the gut microbiome is important for like having or actually having a poor gut microbiome is now increasingly being implicated in these autoimmune diseases, which have gone up
yeah,
significantly. So a lot of people are talking about this dysbiosis in the gut microbiome, like which is a fancy way of saying screwed up biology, basically,
yeah.
where again there's not enough abundance and diversity in our guts. We don't have enough of that. And there was also I heard that there's when they study other cultures, like indigenous cultures that aren't eating a modern, so-called modern diet of processed foods, their gut biome has way more, way healthier, has more abundance of microbes, more species of microbes. So, they don't have a lot of the issues that we have in a society that's eating a modern diet. So,
Yeah. It's it's kind of cool. In this conversation, we were equating efficiency and health, and in this context, and then you're mentioning the microbes might actually just be doing the digestion, but it seems like the efficiency at which they can get minerals from your food and
yes.
put it into the right place in your body, that's kind
Yeah.
of what we're getting at.
And another way to think of it in terms of our health is if the plants don't get certain minerals into their bodies, then obviously we don't get them in our bodies by eating those plants, right?
Yeah.
And so, there was this whole thing of I'll mention another scientist, Donald Sparks. I think he's at University of Maryland, but he did this kind of crowdsourcing study where he looked at how much mineral content there is in all these different soils around the world. He basically had people send him soil samples from all over the world, and they found that there was plenty of every soil they looked at had plenty of minerals to support crops, some of the major crops we grow, right? What was missing in some of them was the biology that goes and gets those minerals, because it
Mhm.
doesn't matter if you have lots of nitrogen in your soil, but you don't have any microbes to access that for the plant, then that plant's not going to thrive. It might get, I mean, that's why I think we've gotten into this mess where we think we need synthetic fertilizers,
Mhm.
where what we really need is more biology in the soil. The synthetic fertilizer is just like a band-aid on the problem. But when you, yeah, but when you basically enhance the soil with biology instead of trying to quote unquote enhance it with chemistry, you get a much better result. And I mean, that's kind of how it happens. And when you look at a forest and it has giant trees in it, nobody's out there spreading synthetic nitrogen. How did that tree get to be a couple 100 feet tall? And then it's got roots that might go down as far as it goes up or nearly as far. How did that happen if we didn't put any synthetic nitrogen on it? Because there are whole systems, natural systems that have existed forever that
Yeah.
provide what that tree needs. Just like, anything in the farm field needs some of the same nutrients and doesn't need synthetic inputs.
Yeah. It's yeah, so just back to the efficiency thing. If you start um dumping nitrogen, then it's yeah, just not getting the efficient outcome. Um so what are you working on next? Are you writing another book, or like what are your next what's the next piece on your agenda?
Well, when I wrote the other one, What If CAFOs Were History, I kind of had this in mind that there'd be a series of books that are all kind of what if,
Yeah.
and they're all just sort of looking at solutions to problems. I mean, it would be a huge deep dive into the what I was talking about with the gut microbiome. But I think that would be interesting. I don't know for sure that I'll write that, but it's someone should someone
Yeah.
should write that. I mean, I'm sure there's books out there that explain it in a beautiful way, but I kind of like this small book format.
Mhm.
And one of my colleagues here, Mike Milley, was the one who suggested, "Hey, why don't we make this into a book with the first one?" And I mean, we write a lot of papers here and submit them to journals, but I think I like the fact that this is more accessible for a general public. I mean, it's obviously I'm not writing it for a scientific audience so much. I mean, it's good for those folks too, hopefully, but I'm writing it mostly for general consumption, and
Yeah.
give people like entry points into different subtopics that are in there.
Yeah, yeah, I appreciate it. People like me, we need these entry points, and it's like I don't have a strong background in this stuff. I'm just trying to
Yeah.
kind of figure out how it all fits together.
Yeah, yeah. And podcasts like what you're doing are a great entry point. I mean, I found that with that, I think I mentioned the Get in My Garden podcast was
Yeah,
one that got me interested in a lot of these topics. And you're doing a similar thing, you know, getting people excited about things that that interest you. And why, if they interest you, why not other people, right? So
yeah,
yeah,
that's what I'm thinking. That's why I started the podcast. Is I
yeah,
want to go deep in all these areas. And
yeah.
who
I think
knows?
it's a
Maybe some
great
other
path.
people want to go too.
Yeah, I think it's a great path, and I think you're doing a great service. So thank you.
Yeah, appreciate it, Leo.
Mhm.
Well, thanks for coming on, everyone who's watching. Leo's books will both be in the description below. Yeah, well, I'll put the link to our first episode as well if you want to dive in and watch that. I'll also link in the James White and the Mike Fedison episodes on similar topics. Those are the regenerative farming episodes I've done so far. Um,
Mhm.
Comment if there's other guests that you'd like me to talk to. Um, and feel free to reach out to Leo if you want to pick his brain.
Yeah, no, that's fine. Absolutely. Yeah, I would appreciate that. And I appreciate the conversation. Thank you.
Yeah. Well, much thanks, Leo.
All right.
And for now, over and out.
All right. See you. See you in a few months, maybe.
Yeah.
All right. Take care, Jake.
All right.